Alright, so in this video we're going to be talking about formal charges. It's going to be a really quick recap about formal charges, so it's going to be a very short video. So the reason why we use formal charges, it's really related to resonance. In this video I'm just going to presume that you know what resonance is. So it's essentially for, the formal charges is essentially for predicting the most stable Lewis structure possible. So let's just dive in straight into the formula. So the formula is the valence electrons, which you find according to their group number, and then the lone pair of electrons, and then you minus it by the bonding electrons divided by 2, and then you get the formal charge. Alright, so for our first example, we have 3 iodines right here. So iodine is in group 7A, so it has 7 valence electrons. As for the lone pair of electrons, and this is for the center iodine, there's 6. So we have 6 right over here for the lone pair electrons. As for the bonding electrons, there is 4 on the center iodine. There are 2 bonds, so 2 times 2, yep, there are 4. Okay, so once we do that, 4 divided by 2 equals 2. And once we subtract 7 minus 6, so the valence electrons minus the lone pair of electrons, we get 1. And then we have to minus 1 minus 2. And once we do that, we have negative 1. And that is a formal charge on the center iodine. Alright, now for the side iodines, again, iodine is in group 7A. We have 7 valence electrons. Lone pairs, same as the center iodine, they have 6. Now the number of bonding electrons, so 1, 2. 2 divided by 2 equals 1. So once we do 7 minus 6 minus 1, we get 0. So 0 is a charge for the side iodine. As you can see, the side iodine over here is the same as the side iodine over on the other side. So we're really not going to repeat the whole process again. We already know that the side iodine, the other iodine on the other side is going to have the same formal charge. Alright, now in order to check if everything what we did right, we're going to have to see if this iodine, I3 has a charge of negative 1. All the formal charges will add up to negative 1 if we did everything right. So we have negative 1 for the formal charge for the center, and then we have 0 for the side, and then we have 0 for the other side. And once we add all this up, we get negative 1, and therefore making all our math right, and we're pretty much good. Now we're going to go on to the second example. So the second example is with methane. So for carbon is in group 4A. So we have 4 valence electrons. As for the number of lone pair electrons, there are no lone pairs on carbon. As for the bonding pair electrons, there are 8. And 8 divided by 2 equals 4. So we have 4 minus 4, which equals 0. So carbon has a formal charge of 0. Now let us talk about hydrogen. So hydrogen has, it's in group 1, so it has 1 valence electron. As for the lone pair electrons, it has 0 on it. And the bonding pair electrons, it has 2. 2 divided by 2 equals 1. And once we subtract 1 minus 1, we get 0. Now again, same concept applies right over here, just like how we did with the iodine, for example 1. We're gonna repeat the formal charges. We don't need to repeat the whole process again, since all of these hydrogens have exactly the same kind of structure, I guess you can say, for lack of better words. But yeah, all these hydrogens have a formal charge of 0. So we're gonna check it again. So we have 4 hydrogens, so 4 times 0. So total for the hydrogens we have 0. We had 1 carbon, so 1 times 0, which was the formal charge, that equals 0. And 0 plus 0 equals 0. And as we can see, this has a charge of 0. So it checks out. Alright, so let us talk about the preferred structure that we will look for in a Lewis structure. So we would like the charges to preferably equal 0. You would also like the smallest non-zero charge to exist. Also, the negative formal charge should be on the most electronegative atom. And yeah, that pretty much sums up this video. Again, like I said, this was a quick video. And yeah, I hope you enjoyed. Thank you, and please like and subscribe.